going to take a look at something we've covered before, but then take it up a level. So previously, in another unit, we looked at area under a curve. And so now we're going to look at a region between two curves. So what I want you to notice is I have y equals f of x and y equals g of x. And I'm looking at the region between x is 2 and x is 4. So I want you to look in the middle first. If the blue curve is f of x, and I'm looking at, well, I think maybe that's a typo then, because isn't that really 1 to 3? Yeah, I think that's just a typo. I'm only looking at from 1 to 3. So if I look from 1 to 3 under f of x, that's this green region here. If I'm looking at, yeah, so this is from 1 to 3. And then here's g of x is the red curve. And if I'm looking from x is 1 to 3, this blue region. So if I wanted to figure out just the region between those two curves, do you understand that I have the underneath twice? And that's defined to be the area under g of x. So to determine the area between two curves is just the integral of the top curve minus the bottom curve. So this is actually very, very simple. This will be a refreshing section. So in a nutshell, is you're taking the area and you're doing the top minus the bottom. And the limits of integration are the x values from left to right. Now we are going to see in 8.5, what if it isn't top to bottom? Then we have a problem, okay? So what I'm saying is the integral of the top function minus the bottom function is only when you have top. There's definitely a top over a bottom. And we'll see in the homework. And tomorrow we're going to do where it's really right to left. And then sometimes you're going to have to break it into two regions to do a top to bottom or a right to left, okay? So it doesn't always work out perfectly, but we're going to start off nicely. So let's look, and we're going to do all three of these with no calculator. So don't touch your calculator today. It says find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x equals 1, and x equals 0. So one of the first things I do is I find any intersections. Now x equals 0 and x equals 1, those are vertical lines. So I don't need to do anything with those. That's bounding my left side and my right side. But what I'm going to do is I'm going to set x squared plus 2 equal to negative x. So I'm going to pause a moment and I want you to find, they actually don't intersect, do they? Because I'm like doing that x squared plus x plus 2, like that doesn't intersect, does it? All right, so this one didn't have any intersections. So if it doesn't have any intersections, let's sketch the graphs. So let's do y equals negative x. That's 0, 0. And then if I plug in x is 1, isn't y negative 1? And I only want this line from x equals 0 to x equals 1. So I don't need to draw the whole line because I only want this small region. Now, let's do the parabola piece. If I plug in 0, that would give me 2. And if I plug in 1, that gives me 3. So this is the piece of the parabola here. And so I'm looking for the area between those two curves from x is 0, that vertical line, x equals 0, to the vertical line, x equals 1. Now, I'm planting some seeds for 8.7 and beyond when we do volumes. When I talk about top to bottom or right to left, here's what I mean. If I could take a slice, everywhere I would slice, I could go top to bottom. There isn't a place where I don't have top to bottom, top to bottom, top to bottom. This will make a little bit more sense tomorrow, but for now, just sort of trust me. So this is a top minus bottom situation. So then my area is from x is 0 to x is 1. The top function is x squared plus 2 minus my bottom function, which is negative x. And then I need the dx. So this is going to go the integral 0 to 1, x squared plus x plus 2 dx. I'm going to pause a moment, and I want you to integrate. Do this without a calculator. Go through the whole process. Yes, you're going to get some fractions. So your integral should be 1/3 x cubed plus 1/2 x squared plus 2x, and I'm evaluating that from 0 to 1. If this were free response, you can leave it like that. You really can. The math teacher in me can't handle that, so I've got to keep going. So I got 17.6. I can't leave it like that, but you may. So what you want to do is, if it's possible to find any intersections, you're going to want to find the intersections. This one didn't have any intersections, but I had an area bounded between the parabola and the line. All right, let's look at example 2. Again, no calculators. It says find the area of the region bounded by the graphs f of x equals 2 minus x squared and g of x equals x. So I don't have an x equals. So let's find the intersections, and that might help us. So I'm going to pause a moment and let you try to determine the intersections, and then try and graph both pieces. I get everything on one side, and then this factors what into x plus 2, x minus 1. So those are going to be my points of intersection for the line y equals x. That's g of x. Then let's grab the parabola. If x is 0, y is 2. At x is 1, they're intersecting, and at x is negative 2, they're intersecting. How about, and this is a parabola that opens down, right? There's symmetry. So I'm looking for the area between those two curves. So then you do want to get in the habit of trying some vertical slices. No matter where I take the slices, I'm always getting top to bottom. So I'm going to pause a moment, and I want to see if you can set up the integral that would represent the area. See if you can get your limits of integration in there. And do the initial where you take the top one minus the bottom one. They will be looking for that. And on the next quiz, like that initial setup is going to be like 2 points. All right, discuss at your tables just your setup. See if everybody got the same setup. All right, so this should be the initial piece. The integral, negative 2 to 1, 2 minus x squared minus x dx. Okay, do we get that? Thumbs up? Got it? All right, so I'm going to pause again. You're going to get some fractions. It's going to be okay. So let me give you a couple minutes head start and see if you can finish this one and get all the way to the end. All right, so let me continue this one. I said negative x squared minus x plus 2. So that was negative 1/3 x cubed minus 1/2 x squared plus 2x. Then I evaluated, I put 1 in, and then I put negative 2 in. That gave me a positive 8/3. Then I had a minus 2 and a minus 4. And remember what I told you? You don't need to automatically get common denominators right away. See if after you distribute something washes out. And this one did okay. This is negative 1/3 minus 1/2 plus 2 minus 8/3. And do you notice that's a plus 6? Because it's a minus 6 and then I distributed. Then look, that's negative 9/3 minus 1/2 plus 6. That's negative 3 minus 1/2 plus 6. Did I make a mistake? Yeah, where did I go? Oh, yeah, thanks. I'm like, wait, I just made a mistake. That doesn't make any sense. Thank you. Got it. There we go. So 6 minus 1/2 is 5.5. You could write 5.5 or 9/2. There we go. Cool. All right. Yeah, so and I did 5, but I wrote 6. I don't know why. Because that's 9/2. All right. In example 3, it says find the area of one of the regions bounded by the graphs of f of x equals sine x, g of x equals cosine x. So there's going to be infinitely many of these, but we're going to try to find the one closest. So I happen to know sine x. This is my sine x. So I'm looking for this region right here. Now, it's not this teeny tiny piece because there's a continuation and it would have the same sort of region. So where does sine x equal cosine x in this region that I've covered? We should be able to know this from our unit circle. So what's this first point of intersection right here? Pi over 4, good. And where's the other intersection here? Say it again. Yeah, nice. And 5 pi over 4. So then again, I do want to check that anywhere I try to take a slice, I am going to get a top minus bottom. And I know that may not make any sense right now. It'll make a little bit more sense after we do 8.5 on Thursday. So then go ahead, try and set up your integral, and then integrate. So I set up the integral pi over 4 to 5 pi over 4, then which trig function's on the top the entire time in this region? Sine. So then you're going to go sine x minus cosine x dx. Then you're going to integrate, that's negative cosine x minus sine x from pi over 4 to 5 pi over 4. So then I'm going to get negative cosine 5 pi over 4 minus sine 5 pi over 4 minus negative cosine pi over 4 minus sine pi over 4. So that's negative. Now cosine 5 pi over 4 is negative, right? So that's positive. So that's 2 square root 2's over 2. So that's square root 2 plus square root 2, which is 2 square root 2.